Hello and welcome. In this video, we will talk about the new feature in version 2022.4 of Typhoon Hill Control Center that improves induction machine component fidelity, induction machine variable resistance. Three-phase induction motors are the largest energy consumers in industry, playing the important role of converting electricity into mechanical power. In addition to this, some industrial processes require speed and torque control, and inverter-based drivers are primarily used for this kind of application. The controller hardware in the loop approach of the Typhoon Hill tool chain is suitable for evaluating the performance of the three-phase induction motors control algorithm in a real-time simulation before it is deployed as a controller of a real drive. Based on this context, the pre-built machine library of Typhoon Hill Control Center is constantly updated to increase model fidelity for real-time simulation. The 2022.4 version of the software brings new capabilities for representing environmental effects on the induction machine's performance, specifically on the resistances of the stator and rotor coils. From this version, those resistances can be modified on the fly during simulation runtime. Let's look at Schematic Editor and see how you can find and configure this new feature. The Machine Online Resistance feature is available for the three-phase squirrel cage induction machine component. The location of this machine in Library Explorer is the same as before, under the Machines category and the Induction Machines subcategory. The Induction Machine Variable Resistance feature is enabled through the Dynamic Resistances checkbox under the Electrical tab of the Components Properties. By selecting the checkbox, the default stator and rotor resistance entries are disabled, and the new values should be defined through the signal processing input port on the top side of the component. Take care with the order of the vector list on the input of the component. The input vector order described at the top of the Components Properties window will show the input order used on the machine's current configuration. This can be modified according to the load source property chosen for a given model input. Now, let's check how to use this feature in a simulation example. We will use a modified induction machine with open loop control model, which is available in the Typhoon Examples library. The original model is modified by enabling the Dynamic Resistances feature. Two SCADA inputs are added that represent the dynamic behavior of the resistances in this case, but you could use generic signal processing components for this instead. Note that for this configuration, we are using a bus join component to append the resistances to the machine's input, respecting the input vector order described on the Components Properties window. After compiling the model and loading it to the SCADA panel, we can start the simulation and evaluate the effects of resistance changes on the machine's dynamics. As you can see, stator resistances have more impact on the terminal currents of the motor, while the rotor resistances have more impact on the motor speed, as expected for induction machines. That covers the key information about the new induction machine modeling feature available in the 2022.4 update of Typhoon Hill Control Center. Thank you for watching.